All right, let's talk about something that is just absolutely essential for any serious serverless developer, and honestly, a huge topic on the AWS Certified Developer exam. We're diving into how you can effectively test your serverless apps using AWS SAM. Because, let's be real, if you've ever worked with serverless, you know the pain of that long wait.
You know the drill, right? You change one tiny line of code in a Lambda function, and then you have to sit there and wait for the entire CI/CD pipeline to chug along just to see if it worked. That feedback loop is just so slow, it can absolutely crush your productivity. But what if you could just not do that? What if you could break that cycle? Well, that's exactly where the AWS Serverless Application Model, or SAM, comes into play. It's this amazing open source framework built specifically to speed up that feedback loop, giving you some really powerful tools to build and, this is the important part, test your serverless apps right on your own machine. So let's set the scene. Let's imagine you're a developer, you're hammering out a new Lambda function. Before you even think about shipping this thing to the cloud, your first line of defense is going to be a solid local workflow. And the very first stop is a unit testing. This is where we test one tiny piece of our code completely in isolation. Now, this brings up a really critical question, one that comes up on the exam. If your function needs to talk to, say, DynamoDB, should you test against the real database or a mock? For unit tests, the answer is almost always to mock the AWS SDK. Why? Well, it's incredibly fast. It isolates your test from any network problems or other services being down. It costs you absolutely nothing, and it makes faking weird failure scenarios super easy. So once your business logic feels solid from unit tests, you've got to test the function handler itself. And for this, AWS SAM gives you this fantastic local testing toolkit. It's really all about three main things: generating test events, invoking your function locally, and emulating your API. First up, how do you even pretend that an event happened to trigger your Lambda? SAM has a neat little trick for that called SAM generate event. This is a really important command to know because it lets you create fake event payloads for tons of services, like SQS here or API Gateway. It gives you a really realistic starting point for all your local tests. Next, we've got the real star of the local show: SAM local invoke. This is the command that actually executes your function's code. Now, for the exam, you have to remember this. This command fires up a local Docker container to mimic the real AWS Lambda environment. It just loads up your code, runs it with whatever event you give it, and gives you the absolute fastest way to see if your handler logic is working.
And what about functions that are triggered by an API? Well, for that, there's SAM local start API. This command is awesome. It reads your SAM template, finds all your API gateway definitions, and then spins up a local web server that pretends to be those endpoints. You can hit it with curl, Postman, whatever you want, just like a real deployed API. And the best part? It has hot reloading, which means when you save a change in your code, it's live instantly. No restarting the server. It's a massive time saver. Now, this all works because of how you structure your SAM template. You see, under your function resource, you define this events section. Right here, we're telling SAM that this function is triggered by an HTTP API event, specifically a GET request to /myPath. It's this exact block of code that SAM local start API reads to build that local API for you.
Okay, so your unit tests are all green. SAM local invoke is working like a charm. SAM local start API is giving you that beautiful 200 OK response. You're feeling good. You're feeling confident. It's time. You commit your code, push it up, and let that CI/CD pipeline take it away to a real AWS environment. And then the twist. That moment we all know and dread. That moment where your local success just does not translate to cloud reality.
The deployment finishes, you go to hit your API endpoint, and boom, access denied exception. The function that was working absolutely perfectly on your laptop is now completely broken in the cloud. It's got to be one of the most common and most frustrating things in serverless development.
So, what happened? I mean, our local testing felt so thorough, but it obviously missed something huge. What is it that our local environment just can't see? So here's the absolute key takeaway. Local emulation is not a perfect copy of the cloud. The #1 biggest difference is IAM permissions. When you run SAM local invoke, it's using your AWS credentials from your machine, which are probably pretty powerful. It does not check the function's actual execution role. So that access denied exception, almost certainly a missing IAM permission in the function's role that we never tested. Local tests also have no idea about things like service quotas, or weird cloud configurations like an SQS visibility timeout, or just those subtle little differences in how the real services actually behave.
And that brings us to the resolution of our little story, and probably the most important best practice for serverless development. You absolutely have to supplement your local workflow with testing in a real cloud environment.
And hey, you don't have to just take my word for it. AWS's own official guidance is perfectly clear on this. Testing against your actual deployed resources is the gold standard. It's the only way you can truly validate your configurations, your permissions, and your real service integrations. This is where you catch all those sneaky bugs that local emulation just can't see.
Now, a really common question I get is, okay, that's great, but my whole team deploys to the same dev account. Aren't we just going to be stepping on each other's toes and overriding each other's work all day? And that is a very real, very practical problem.
Luckily, there are two really clear best practices to solve this. The absolute best solution is to give every single developer their own dedicated AWS account to use as a sandbox. But if you have to share an account, the key is to make sure every developer deploys their stack with a totally unique name. A super common pattern and something to look out for on the exam is to just add your username to the stack name when you deploy. Something like samdeploy-stackname dvasquez my API stack. This creates a completely separate, isolated copy of all your resources.
Okay, let's pull all these different pieces together. We've looked at the strengths, the weaknesses of these different approaches. So what does a complete, professional serverless testing strategy actually look like?
Well, it's a multi-layered approach. You always start with those fast local unit tests using mocks to make sure your core business logic is sound. Then you use SAM's local emulation tools for that super fast feedback loop on your handler and your API definitions. But, and this is the most important step, you finish by deploying to an isolated cloud environment to run your real integration tests. This is where you validate the actual permissions, the cloud configurations, and the real service interactions. And hey, once it's up there, you can use a command like samlogs to tail the CloudWatch logs for your specific function right from your terminal. See, each layer is designed to catch a different kind of bug.
So, I'll just leave you with this one question. The next time all of your local tests are passing and everything looks green, ask yourself, is this code just working on my machine, or is it actually truly production ready? Because adopting this multi-layered strategy is really the only way you can answer that question with confidence.